Hi there and welcome again. We're looking at circles in analytical geometry, and in the previous video we saw that the general formula for a circle, there's an example, a circle with a center PQ, and it has a radius of r. The general formula for that one is that the distance between any point xy and the point PQ is equal to r. Okay, so we find that distance by taking x minus p squared plus y minus q squared is equal to the distance between those 2 points, which is r squared. Otherwise it should be the square root of that. Okay, that's what we saw in the previous video, but what we also noticed, or what we're going to see in this video, is that we don't always have the luxury of having this nice format, because if we multiply this out, we get x squared plus 2px minus 2px plus p squared plus y squared minus 2py plus 2qy plus q squared equal to r squared. So what you will notice is that p squared, q squared and r squared, these three values are all constants. In other words, they could be added together. Minus 2px plus y squared minus 2qy is equal to, if we just add all three of these values together, we could just get some constant, and in that constant we wouldn't know how much of that constant used to be p squared, how much of that constant used to be q squared, and how much of that constant is supposed to be r squared. So what we will have to do, if we're given a formula like this and they ask us from this formula to find the center and the radius, we will have to first find we'll first have to write it into this format. Now, to write into this format is not so difficult. All we need to do is complete the square. Do you remember how to complete the square? Well, notice here the relationship. Here we've got 2p's in front of the x value, and what we want is we want p alone and squared. So whatever is in front of the x value, we will halve it to get rid of the 2, and then we will square it so that we can have p squared. So let's look at an example. I think an example illustrates this well. Let's say x squared minus 8x, and actually let's do this just to make it exciting. Why not? X squared, red is pretty exciting. Okay, plus y squared plus let's go for 12. Y is equal to something like let's go for minus 3. Okay, let's see if this one will work nicely. Well, we can see that my negative 2p is equal to 8, and we can see that my negative 2q is equal to 12. So I can very easily see, well, then the value that I need to add, since p will be equal to 4, I'm just solving p, and q will be equal to negative 6. The value that I'll have to add here is x squared minus 8x plus p squared. So half of what's in front of the x, okay, it will always be half, which is 4, a negative 4 actually, but I will square it, so it will be positive 4 squared is 16. Now be very careful. What I'm doing on the left hand side, I'm literally adding a 16. I can't just add a 16. What I do on the left, I have to do on the right. So I'll say, well, on the right then we have negative 3 plus 16. Now also for y value, plus y squared plus 12y, and now again q is negative 6. I want a q squared, so I'm taking negative 6 squared, which is 36, so I'm going to add a 36. Or you could just say, well, what's half of the value in front of y? Half of that value is 6, and I square it, so that's 36. So plus 36. And then you simply put this into two brackets. Now, these two brackets must be two equal brackets. That's the whole point. We're trying to complete the square. Now, so I'm not going to write out two brackets. I'm going to write out one bracket squared. And it will always be x minus half of this value, minus 4. But if you just do normal factorization, you will get the right bracket. Okay, so, and that one will be y plus half of what's in front of here, that's 6 squared. And now on the right hand side, 16 and 36 is 52, minus 3 is 49. Excellent. Can you see what is our radius? Our center and our radius. We make x minus 4 equal to 0, so x is equal to 4. We make y plus 6 equal to 0. That gives me y is equal to negative 6. So we have my center is the value 4.6, and my radius is the value square root of 49, which is 7. Excellent. And there we have it. That is how I would go about to find the center and radius if I have an expression where I'm not necessarily already factorized into the pretty brackets right here. Well, thank you very much for watching. We'll see you in the next couple of videos where we will do as many as I can examples, different type of examples of how these questions might be asked. We'll see you there.